want to bring on Dominic here, who is the founder of DFINITY and Internet Computer, and he is the Chief Scientist at DFINITY Foundation. We're going to have a discussion on kind of how we actually can think about exploring the possibilities with blockchains. We're going to look at AI on-chain, how we make chains more accessible, and a lot more in between. So without further ado, please welcome Dominic on stage. Hi. Good timing. So I want to start off by you kind of giving us a refresher on the world back 6-7 years ago. When you came up with DFINITY and Internet Computer, what was kind of the original goal, and what made you start this as a project, and how does it compare to where things are now?
Actually, it was incredibly 9 years ago. So if you go to the Wayback, the internet's Wayback Machine, and type in DFINITY.io, you'll see the original DFINITY website from 2015 that describes the vision of creating crypto ledgers that can scale infinitely and could potentially host something like a search engine or Gmail. So the DFINITY project was, I was part of the early Ethereum community, sort of 2014 onwards, and there was this phrase world computer, and I had my own interpretation of the phrase world computer and decided that needed to be built. And the vision essentially is that you can extend the internet so that as well as the internet connecting software, it can host software. But of course, it's software superpowers, it's smart contracts. And I saw in sort of 2014, 2015, when this kind of stuff started, we first started working on the stuff, that smart contracts are really a new kind of software. And this new kind of software has amazing properties. So it's hosted on the network, obviously. One of the properties is that it's tamper-proof. A smart contract is guaranteed to run the logic as written against the correct data. And in a sense, you can think of that as meaning that a smart contract is immune to a cyber attack. You don't need to protect it with a firewall or anti-malware to stop it being infected with ransomware or something. So, for me, that was a big deal. Obviously, a smart contract's always available. It doesn't crash. It's not like a software running on a traditional server. You can make it autonomous, which means that you can get rid of human controllers either by making it non-updatable or putting it under the control of a DAO. It's composable. So I saw that all these properties existed, and so my conclusion in 2015 was inevitably smart contract software. I don't think it will be called smart contracts forever. It's a very silly name. Came from Nick Szabo. But network resident, blockchain resident software will actually become the default backend software eventually. And it's just completely inevitable because of these huge advantages. And so I said, well, okay, if it's inevitable, let's bring it on and let's try and create a blockchain that has the speed, efficiency, and ability to scale without bounds that's required for a world computer.
Awesome. So fast forward to now, we have a functioning world computer, or internet computer, and in the last 2 years especially, we've seen a massive wave of AI applications. And a big part of that is, well, people are worried about who gets to control these models. And this is a perfect example for where blockchains can come in, or just generally large compute actually helps. So what I'm curious to understand is kind of how do you think about AI actually getting more on-chain natively, and what do you think are the possibilities here?
Yeah, so as always, we tend to see things differently to the rest of the crypto industry. And, for us, like when people say, what's the intersection of crypto and blockchain? We see AI running on chain, and we also see AI building on chain. So, first of all, we think AI should run as smart contracts. And yeah, it's true that you can put it under the control of a DAO and so on, but there are actually reasons why enterprises are going to want to do this. So, we were already familiar with the problem of creating a hot wallet, creating some kind of Web 2 website, which has got a private key inside the back-end code on Amazon Web Services that maintains a hot wallet. Sooner or later, someone will hack into that, take the key and steal all the crypto. Well, AI is like that, but with data. So if you want to run your own AI, and increasingly people are doing that because they don't want to upload all their data to, OpenAI or Anthropic or X and whatever. The challenge is that, probably you're running your own AI because the data is very confidential. Like imagine a law firm, a law firm with 100 or 200 partners or something, and this AI maybe has a context database and it's downloading all of the emails with clients, all of the previous legal filings, relevant case law, legal texts, and the partners want to speak to this AI and get answers to assist their clients or prepare for trial. Will be extremely useful for them, and maybe they built it using Llama 3 or something. But the problem is, if it gets hacked, the law firm's over, and they're going to ruin the lives of their clients, because in order to be useful, that AI has to have access to all of that super confidential information. And that super confidential information will be in one place. So if you put it on Amazon Web Services or some kind of traditional Web 2 tech, you've created a hot wallet for sensitive data. And of course, that's what cyber attackers will zero in on. And there's no way of keeping Web 2 tech secure. You can think you're a security expert, you can think you've securely configured Linux in your database, and you've got a firewall and your anti-intrusion monitoring software and your anti-malware. There's absolutely no way you can be sure that some software patch, some zero-day exploit, something won't let an attacker in. It's just a matter of time, really. And cybersecurity is about to get a whole lot worse with AI, because AI can already hack systems very effectively. But GPT is locked down. But if you can get hold of an unlocked version of GPT, you can use it to already hack. It's been demonstrated, systems very widely. So you've got this problem, like you're this law firm, you want to run an AI model securely. You don't want it to be a hot wallet for your client's data, whereby if it gets hacked because it's running on Web 2, all of those confidential emails with your clients, all of those legal filings, and so on, make it into the public domain, blowing up your law firm and ruining your clients' lives. So you're in this kind of, what do you do? Well, our answer is that you run your AI as a smart contract. On the internet computer, it's to some extent privacy preserving, and you can also run a private internet computer to control the nodes, and that means even if someone has hardware access, they can't get it.
Mostly for curiosity, is there a distinction between what running it as a smart contract means? Is it inference we're talking about? Is it training? Is it just calling it? Or is it all of the model storage? Or all of the above?
Well, we think actually there's going to be a mix of models. I think sometimes people will run centralized models and just keep a vector database in the smart contract, but we're also very keen that AI models run as smart contracts. So far we've demonstrated image classification running as a smart contract, and we've demonstrated facial recognition running as a smart contract. So if you're from the Ethereum world, you have to reorient yourself a bit. So the internet computer currently is running the equivalent of about 1.5 million Ethereum transactions a second. So that's just measuring it in terms of the virtual machine instructions executed. So,
okay, so it's like the
so
instructions and flops instead of
it's capable of much more. So, I forget how many WASM instructions are involved with, like image classification inference, right. But it's like in the billions. I think it's like 20 billion or something. So, you need, in order to run AI as a smart contract on the blockchain itself, you need like a special kind of network that's much more efficient. But currently, we're sort of stuck at we're stuck at facial recognition, and I'll tell you why. The internet computer runs each smart contract. It's like an independent software unit. There's parallelism, but it runs each software unit, each smart contract, in a 32-bit environment. And so it's got 4 gig basically. So when you've got so it turns out that you basically can just double the number of parameters to see how much memory you need. So the facial recognition needed 2 billion parameters, like weights, AI model weights. So that means you need 4 gigabytes of memory to run the smart contract in. So if you look at Llama 3, it's like 8 gigs. But within weeks, the internet computer hopefully will be upgrading, and the smart contract execution environment will go to 64-bit, and the memory
Because you're
limit,
bypassing WASM or how?
No, it's going. I mean, we're very lucky. So actually, the WebAssembly inventor was an early DFINITY guy. So we've always, played very well with the, we've always known how to use WebAssembly and push changes into the standard and being aware of changes coming and so on. So WASI time, which is the environment. Yeah, that's moving. There'll be a 64-bit version soon.
Oh, that's awesome.
And
because this is like now just me personally trying to understand, because you're now representing floating points specifically differently, or is there actually a benefit, or like is there actually some innovation around getting the 64-bit?
So that's it turns out there's not a problem with floating points, the determinism, right?
I promise everybody won't be technical, but we'll just do this.
WebAssembly processes floating points deterministically. No, we spent a lot of time optimizing the internet computer smart contract execution environment for AI. So for example, we added SIMD instructions, forget what it stands for, like single instruction, multiple D, I forget what that stands for, right? But it essentially allows you to do multiple calculations in parallel, a bit like a matrix calculation, right? So, there's been lots and lots of optimization. And in fact, since the first demo, which was image classification, I think we got almost like a 10x speed up for running, for AI inference. But in order to get like large language models onto the blockchain running as smart contracts, we need to increase the memory because they have more parameters. So the smallest distillation of Llama, or one of the smallest, is like...
you still need like 80 gigs of RAM.
8 billion parameters, yeah. By the way, it's still a very powerful model. You can do a lot with it, and it's going to be incredible to have that kind of model running as a smart contract. And we've got other technical innovations coming, which we think is going to make it very easy to boot up and very inexpensive to boot up smart contracts with AI inside, like memory mapping parameters and stuff like that. So there's a lot coming. Yeah.
And also just in the same scenario, how does it work when you have to delegate something to a GPU? Because a lot of this context will be CPU based for a lot of these inference, but can you actually pass this on to a cluster of GPUs?
No. So at the moment, the internet computers, Ethereum runs on the cloud, right? Like people create proof of stake validators and then you interact with it by the cloud. So internet computer, I suppose, is a more like puritanical project. And it's all sovereign hardware. And basically, in order to add nodes, they have to be like they're specialized hardware built to a standard. There's a bunch of reasons why that's necessary to run them with the protocol. But there's no GPUs on the nodes. We're trying to get to the point where we can create a spec for node machines with GPUs. But it's okay because inference is actually pretty efficient. So, when you're talking about running Llama 3 on the chain, for a legal company or for a smart wallet, you want to tell the wallet...
You can map the requirements.
Yeah, like if wrap Bitcoin hits 100,000 swaps, sell half for USDC, swap half for USDC.
But also, you don't need to optimize for I don't need 500 tokens per second. You can be okay with 20.
GPU, OpenAI is serving, millions of concurrent users. Most of these smart contract applications aren't doing that. So it's fine. Inference is actually fine without GPUs, albeit, of course, we want to add them. What it does mean is currently you can't train the models on-chain yet.
You can put them after, and then you get to use them. Okay.
But typically you won't do that. Typically, what you'll do is you'll take a pre-trained base model, like Llama 3, a distillation of Llama 3, or Phi, or the whole bunch of other ones now. You take the distillation, and then what you do is you combine it with a vector database, and that contains the custom the context, right? And so when you want it to do some inference for you, you first take the prompt, turn that into a vector database query, basically turn it into a vector. You get all the content, which has got the shortest vector distance, and then you prime the chat stream, the session. So you say, hey, Llama 3, here's some background information, now answer this question. But of course, the user doesn't see that, they just see the question they've asked, right? So typically, that's how you'll do it anyway. But at the moment, if you wanted to create like a LoRa, like these kind of patches or incremental fine-tuning training, you still had to do the off-train. You can't do that.
Which is okay.
Which is okay. It's still very, still very, very useful because, the smart contract tells you, look, this is the hash of the AI parameters. So you know exactly what you're running. When you run the inference on chain, you're guaranteed that it was the AI with this code hash, with this parameter hash, that ran this input prompt and it produced this response. So, it's hack proof. You don't have to worry, about.
Yes, and also as a nice side effect, you actually get to map and prevent hallucinations, because you will be actually able to detect where the hallucinations are happening and correct for it.
Well, the trouble with hallucinations is it's a feature of transformers, unfortunately. So, that's another subject. But I think the big
you'll have a trace for like where it starts.
what would be really nice is like on-chain training, but for that we do need GPUs. So the challenge with GPUs is they're non-deterministic. It's not actually the floating points. It turns out when you ship AI calculations onto GPUs, it's like all these different matrices, and the calculations are performed in parallel, and then the results are going to more calculations and so on. And the sequencing of those calculations is non-deterministic. And that's why you can't have blockchain nodes or GPUs yet. But it turns out that, obviously we've got a team of people working on making the GPUs deterministic. Obviously we're going to sacrifice a bunch of performance, but that's okay, right? If we lose half the power of the GPUs, but we can optimize, we can start doing training on chain, it's okay. But it turns out that there's quite a few other fields that want to find ways to make GPU calculations deterministic. One of them is fully homomorphic encryption. So there's a bunch of people trying to make fully homomorphic encryption practical by optimizing your GPU hardware. And they have exactly the same need. You've got to make it deterministic. So I think, it's a problem that will get solved. I don't know when it's going to get solved.
It's like unsolved. You just get to optimize it and make it faster, right? So that the goal becomes performance, not binary. Is it possible or not?
Yeah,
is that fair?
I think with respect to like why would you run an AI on chain? You're not trying to be GPT. You're not trying to be Claude. You're not trying to be Grok, right? There's a specific sort of bunch of use cases. One is like you want to run a custom AI, and it's incredibly important that it's immune to cyber attack and people can't store the data or can't corrupt it. For example, as per the case with lawyers. Another one is, maybe that it's a smart wallet and you want to, talk to your smart wallet and say, look, I'm on the beach. If Bitcoin hits this price, swap half for USDC, that kind of thing, right? So again, in order for you to be able to trust the AI, it needs to be a smart contract. Ultimate performance, isn't why you put it on the blockchain. The performance has to be sufficient.
Right.
But the reason you're putting it on the blockchain is because you want it to be immune to cyber attack. You want to protect the data in this case.
You're getting better guarantees around sustainability.
Or it's always available. And imagine like in the case of the lawyers, the law firm, these partners discover with the AI, instead of taking 3 weeks to prepare for trial, it takes 3 days. So then the lawyer leaves it. He doesn't start preparing until 3 days before trial, but he goes to his AI and it's on Web 2. And something's gone wrong, right? The hard drive has crashed and he's lost all his data. It's been encrypted with ransomware, I don't know. And now the AI is not available, but he's completely screwed because without the AI, it takes 3 weeks to prepare for trial, but he's only got 3 days because he thought he'd have the AI. So resilience is incredibly important. So, people can put AI on the blockchain to benefit from these security and resilience properties and things
also,
like that.
one other thing that...
And autonomy in the case of a wallet, of course. Yeah.
Well, that, and also like people will start doing custom AIs that they would like to make money off of, and they get to put that model, and
totally.
you get to say, hey, this is very customized model that specifically solves this.
The other last one is, if you look at the internet computer, you can create a social network with just one piece of serverless code. serverless code to us is a smart contract, right? With these properties. You have to have a special kind of smart contract that can process HTTP and so on. It turns out, and also the way that the way that you describe an application, a web application, is very abstract. Because in the case of the internet computer, like the logic runs in persistent memory pages. It's called orthogonal persistence. So, you just describe your abstractions and the data lives in the abstractions. So it's ideal for AI. And there's some other innovations coming that, when you upgrade a smart contract, there's some new languages that'll be available in about a month, this functionality, which have type safety. So if you're transforming your data structures, you get some safety in that the transformed data won't be lost. So basically the AI you can talk to the AI, we've got this running, of course, talk to the AI, it creates a system for you, gives you a URL which is basically something you can use to interact directly with the smart contracts, right? That's your web application. You can use that web application, put data in it, and you can actually have the AI upgrade the running system. And we think that's really the future for all tech. Like in the future, if you're talking about like stuff that's like, an information system like Salesforce, like nobody's going to go and like rent this thing and then try and customize it using the hooks. Instead, you'll just go to the AI and say, hey, give me a CRM. And it's going to give you a CRM, which is your own CRM.
It's custom to you, yeah.
Yeah, you control all the data. You're not uploading the data to a third-party service provider. It's your smart contracts, your data, you control it, you got the keys. And now you just keep talking to the AI and it just keeps on updating it and customizing it and adding the features that you want. This is going to be the new paradigm. So one of the other really interesting things about blockchain is when you can make it an end-to-end stack, it's also the ultimate stack for AI to build things on. And if you think by comparison about Web 2, how people do it today, how would the AI do it? The AI would you can't just upload a piece of abstract code. The AI would have to go to Amazon Web Services.
So provision a server, pay for the credit card.
Precisely. Yeah, go to get an Amazon, sign up for Amazon Web Services, put a credit card in, create some instances, provision servers, set up databases, patch them, configure them.
Get on a call with the sales rep for that enterprise software company.
Kubernetes, set up cybersecurity, load balancing. I mean, it's a nightmare, right? There's no way the AI can do that. And then imagine how on earth would you upgrade that running system safely? How could you trust that it's done it safely? How would you trust that it's done the cybersecurity in a way that's going to... So look, it doesn't work, really. I mean, it can assist, like GitHub Copilot can help you write, but it's not going the whole way. The future is you just talk to the AI and it modifies stuff, unless it's something very specific, like a social network.
It has enough context into what it can and can't change.
Yeah. So, that's the other dimension, that we're going to see blockchain excelling as being the platform for AI because it simplifies R&D. Yeah.
And it looks like you're already doing a lot of these experiments, and enough things are live on the chain right now for you to kind of actually show that this is actually possible, which is awesome. My last kind of question to you would be, I know we'll have to keep this very high level, but in this world, models exist on ICP, people get to use them, and we obviously want other chains to also be part of this, and you kind of have a whole platform around this for chain fusion. How does that work at a high level, and how do you get to make this work with multiple chains?
So in the last year, the internet computer has been upgraded with this called chain key capabilities. So smart contracts on the internet computer can sign transactions on other blockchains like Bitcoin and Ethereum without having a private key. The blockchain itself acts as the private key. Of course, behind the scenes, it's using a complex assembly of threshold cryptography, the world's only non-interactive DKG, key resharing, and all this kind of stuff. But essentially, it allows a blockchain to be a private key. So now, you can have a smart contract that generates a bunch of public keys and can sign for those public keys. So for example, the public key now with the chain fusion tech, you can ask the smart contract, give me an ECDSA public key for an EA, Ethereum account, for example, and now you can sign for it. So the actual internet computer network is integrated at the network level with Bitcoin and Ethereum. Bitcoin was the first, Ethereum is a more recent integration, and the single chain key ETH and stuff like that. Anyway, the point is that you can do smart contract call level integration. So it's possible to have smart contracts on Ethereum, like DeFi smart contracts on Ethereum, and you can build the rest of the infrastructure, like the interactive user experience, anything which involves AI, storing and processing large amounts of data. You can build it on the internet computer, and smart contracts on the internet computer can interact with smart contracts on Ethereum in a trustless way, using chain key cryptography. You can even there's a special kind of DAO you can use on the internet computer called a service nervous system. And you can even put like smart contracts on Ethereum under the direct control of a DAO on the internet computer.
That's awesome.
Yeah, alongside the user experience and the AI and the data and whatever else there is on. So, that's the world computer vision, that you just keep on building this stuff out and amalgamating stuff. But it's a very effective way of, like, if you want to fully decentralize and get rid of Web 2, and it's worth remembering, like, nearly all the hacks and things that go wrong in this space, apart from re-entrancy bugs in the EVM, apart from that, it's nearly always some kind of bridge or Web 2.
It's a human-controlled area.
Yeah, and so there's a reason for decentralization, and if you really want to fully decentralize your projects and make them more robust, and put them maybe under the control of a DAO, but automated control, not like decentralization theater when people vote on a piece of text and then the administrator goes away and uses his backdoor key, like fully automated, fully autonomous, decentralized control. Internet computers are a great option for that.
Amazing. Dominic, thank you so much for this amazing conversation.
Thank you.
Looking forward to seeing more AIs on chain.
Yeah, thanks, Kartik. Thank you.